what I'm going to cover actually is related to what Mr. Munguia studied in college. Do you guys know what I majored in when I was in college? It wasn't mathematics. I wasn't a math major. But what I'm going to cover today is related to what I studied in depth. So what I studies ideologies and critiques them, but that's not what I studied. Archaeology is when you uncover old artifacts from old cultures and civilizations. Theology is a sub-branch of what I studied. That's meteorology. No, I didn't say meteorology. Let's play hangman. I know. It's like a bad message. Okay, as we play hangman, let me put this on. So reasoning that involves drawing a conclusion, called a conjecture, that is based on patterns observed in the past. Rational? Did you finish writing that first? And I'll tell you. You finished? That is a subject of controversy. That's debatable. Some thinkers say we never evolved. We were created by a higher intelligence. You may want to call him God, or you may want to call him an alien or something, but we never evolved from lower life forms. Man as a species has always had these capacities. And they're given to us by the higher being, or they're given to us by some alien being that was more superior to us, that created us. That's another topic for discussion, but that's one school of thought. Another school of thought says, hey, well, just through billions and billions of years, we evolved this capacity to think this way. There's two schools of thought. This way? I would encourage you to study it. It's still a topic of hot debate in universities and academic institutions. So, you and I, we do this kind of thinking every day. Literally. You do this constantly. You think based on past experiences. When you get up in the morning, what's the first thing you do when you get up in the morning? Maybe like grab your phone and look at it? No, you probably grab your phone before you brush your teeth. Don't even lie. You're lying. Okay. Now, when you go into the restroom, do you open the door of the restroom?
No, actually, I take a shower and then I brush my teeth.
Okay, watch this. But when you open the door of the restroom, what do you expect to be in the restroom? The shower, the toilet, the sink, right? See, you conclude that there's going to be a shower, a toilet, and a sink based on your past experiences. But for all you know, while you're asleep, yeah, or someone's going to be in the toilet. Maybe a robber, or some tweaker who snuck in your house and he's there taking a crap or something. Whatever. But notice, if we get silly and funny, my point is this. Most of what you do from day to day, moment by moment living is based on inductive reasoning. You conclude something's going to happen because of the past. But there's no guarantee that what's going to happen is going to be the same as the past. That doesn't mean inductive reasoning is bad. It's just the way we typically move and live and interact day to day. Like when I go home today, I get on my scooter, I put the key in the ignition. What do I do when I put the key? Turn the key. So I conclude that scooter is going to start when I turn the key. That conclusion, which is called this, is based on, look at this, it's based on patterns observed in the past. I've noticed in the past when I turn the key, my scooter starts. So my conjecture is today, when I get out of work, probably at 4 o'clock, my scooter is going to start based on past experience. Let me give you another example. It should start. based on past experience. Go. You conclude what's going to happen. You're not sure though, huh? 100% sure you're not. But you're pretty confident based on past experience that something's going to happen. Just think of the restroom example in the morning. Okay? It might not be that the toilet's in there. Or when you turn on the shower, you turn that faucet, the knob, you assume water's going to come out, right? But it could be the case that the city had to turn off the water for some emergency. Okay? That's what I mean by inductive reasoning. Let me give you an example of inductive reasoning. Ready? Watch this. Go ahead and draw that. Where it says notes, give me a little circle, then give me 3, a cluster of 3, then give me a cluster of 6. Do that for me, please. 1, 2, 3, 4, 5, yeah. Go ahead and draw that. Yeah, the little section where it says notes underneath. Because it gives you another definition of inductive reasoning. There's a place for notes there. What would be the next picture in this pattern? Okay. So what he just did, his conclusion is this. It's going to be this. 4 at the bottom, 3, 2, 1. His conclusion, Rivetta's conclusion that the next one will look at that, that's an example of inductive reasoning. It's from past observations. There's a pattern going on. 1, and then you put 2 underneath. Underneath the 2, 3. Underneath the 3, we can go 4, and so on. Okay, that's inductive reasoning. Okay, now, skip conjecture. We're going to deal with conjecture tomorrow. And let's go on to deductive reasoning. So, counterexample we'll deal tomorrow. Go ahead and flip the page to deductive reasoning. And you'll see this definition. Look at this kind of reasoning. Okay? Underline the words with me. Deductive reasoning uses facts, definitions, accepted properties, and the laws of logic to form a logical argument. This is different from inductive reasoning, which uses specific examples and patterns to form a conjecture. So go ahead and underline what I just read, or just what I just underlined there. Deductive reasoning uses facts, definitions, accepted properties, and laws of logic. Okay, so you have some area for notes, and we're done. We're going to go over one example. So skip that where it says laws of logic there and go to where it says notes here. Okay? You're there, Toscano, where it says notes? So we're skipping those it says laws of logic, it says law of detachment, law of syllogism, skip that. Where it says notes, go on and write. Let me give you an example. Go and write example 1, EX1. And go and write gizmo equals dinglehopper. What the heck is that? What the heck is a dinglehopper? That's weird. For now, let's just say gizmo equals dinglehopper. Do you know what a dinglehopper is? It tells you right there what a dinglehopper is. It's a gizmo. Wait. What's a gizmo? A dinglehopper. What's a dinglehopper? Okay. Stay with me. Here's the next line. Dinglehopper equals thingamajig. Go write that. This is still example 1. We're going to get into, this is deductive reasoning. You know what inductive reasoning is? Think of the shower in the morning. Think of my scooter when I turn it on. Now I'm going to get, now I'm going to get into, I'm going to get into deductive reasoning now. Gizmo equals dinglehopper. Dinglehopper equals thingamajig. Do you know what a thingamajig is? No. What's a thingamajig? Hold on real quick. What's a thingamajig? Tells you. It's a dinglehopper. So far, so good. Why? Yes, I did. Watch this. A thingamajig is a doodad. I'm going to write that one more time. Go ahead. It's still example one. Well, right now, that would be a wrong conclusion. That wouldn't be, right now, Gizmo is dinglehopper, dinglehopper is thingamajig, thingamajig is a doodad. You don't know, you know what is. Right. Here we go. You definitely know that thingamajig is a doodad. And doodad is a puppy. We're almost done. So right now, what can we conclude from this? What's a puppy? Why would you say a dinglehopper is a puppy? Wait, you got it. Go ahead. Or, yeah, exactly. So all that's called deductive reasoning. That's different than that kind of reasoning. Okay, this has to do with philosophy. These are the two kinds of reasoning we do as human beings. There's actually one more, but I'll get into that later.
So inductive reasoning is what you think will come next?
Based on patterns in the past. Deductive is, okay, if that's that, and this is that, and this is that, and this, then this has to be that. That's deductive reasoning. It has to do with categories. So look, here's my final conclusion. So here's what we're going to do. Going to put three dots. This is a symbol for therefore. I'm going to make a conclusion. Look at therefore. Go and do this on your notes. Therefore, whenever you see me do 3 dots, that's a symbol in logic that means therefore. I'm going to make a conclusion now. What's one of your conclusions you made? Well, is equal to what? Well, we already know that. Don't. Gizmo's a puppy. Look at it. Write that. Therefore, Gizmo's a puppy. Right. At this point, you can even say a dinglehopper's a puppy, a thingamajig's a puppy. They're all equal to each other, huh? See, that's based on chain reasoning. There's a property of logic we're going to get into later. A gizmo is equal to a puppy. That's deductive reasoning. All right, that's it for today. Grab your Chromebooks. You're going to do a grade check and a credit check. Do not lose your notes because we're going to continue those notes tomorrow. Do not be absent. Right now, you're going to do a grade check and credit check and then go on your assignments.